Greetings of the day. Today, on the occasion of project demo presentation, I am presenting my topic AirOPS-AI. So this is particularly the second part of my video. And in this part of the video, I'll be going to cover the demo of my code file. Let's start with it. So first of all, there are some hardware and software requirements. Before that, I have chosen particularly a cloud-based platform, Google Collaboratory. It is a platform where we can work with a number of programming languages. So I have chosen Python for development of the whole project. And also the same thing, you can work with the Jupyter Notebook as well. And these are the hardware requirements for it, like the computer and the server, like minimum of 16 GB, and then the GPU specifically because you are working with the computer vision and OpenCV, and these are some of the software requirements of it. Let's start with the structure of the code files. There comes four components in which the first one is airline operations optimization, second one is flight delay prediction, third one is real-time analytics, and the fourth one is video surveillance and security part. In the first part of the project, let us go to the code files of it. So since I have developed the whole project on Google Collaboratory, the files are also stored on the drive, so nothing is like uh, installed or downloaded in the system, which is a plus point because it then becomes platform independent and more portable because anyone can run it anytime without any particular need of the system-based thing. Start with the passenger satisfaction point of view. So in the passenger satisfaction, there are some basic libraries, and then the sklearn library, which is used for the model training part, data exploration, data cleaning part, in which the like outliers and the noise in the data was removed. Also, we have performed in this particular file extensive kind of data exploration in which each and every graph can infer some of the points. I'll take one of the example from it. Let's say it's about this graph, then like for the business, this kind of age from 30 to 50 age tries to go with the business class, and then eco class is like from 20 to 50, and then eco plus. Also about the classes, we have age-wise distribution with the bar plot. So each and every plot from it and for some kind of findings. All these kind of visualizations we have performed using C1 and the matplotlib library from sklearn. And there comes the outlier detection part, in which there were some outliers in the flight distance and some of the columns of it which we have dropped. And then here is the classifiers which we have used. In this particular file, we have used 10 classifiers: logistic regression, linear regression, random forest, gradient boosting, KNN, like no nearest neighbors classifier, and then Gaussian NB, MLP classifier just to work on some neural network kind of thing, and then XGB classifier, cat boost classifier. So after performing the training on this, we have the result with us, which is this particular graph. In this graph, we can see the accuracies, balanced accuracy, training accuracy, testing accuracy, F1 score, and various like precision and recall scores. So from this graph, we can see that XGBoost is performing well. So after installing the PyCaret, we have focused on XGBoost, and then we have trained the final model using it. And this is the final graph of the receiver operating characteristic of it, which is like the way as it should be. So it is performing well. Let us go ahead with the next part, which is about the flight fare prediction. In flight fare prediction, we have a data set which says about the source city, departure time, arrival time, and again the various other factors. As per that, again, we have performed extensive exploratory analysis, and each of the graph infers some kind of findings. Like let's say about this graph, it is ticket price versus the duration of the class, and days left for the departure. We can see the price is increasing as per the particular airlines. In this one, we have trained the model using linear regression, decision tree, random forest, KNN, extra tree regressor, gradient boosting, and again the one with the best for, we have performed final training with that. And here is the actual graph of the actual price versus the predicted, like the resulting graph of the actual price and versus the predicted price. Again, it's performing well in its nature. In this one, I think we have moved ahead with the extra tree regressor because it's with the highest accuracy, and almost extra tree regressor, bagging regressor is performing almost same, also random forest. So we can choose any of them and then we can develop such kind of graph. Let us move ahead with the third part of the project, which is about flight delay. In flight delay prediction, we have such kind of parameters in our data set, and then performed, first of all, exploratory data analysis, and then we have developed a neural network um, with like three three model of, like let's say it's kind of three epochs, in which first, in the first neuron we have 500 250 10, and then we have 500 250 20, and in the third we have 150 50 neurons for each particular hidden layer. And then also perform the model training with a decision tree and random forest and the ensemble model logistic regression. And then we are here with the delay prediction results of it. Let us move ahead with the next part. The next part is about the BI dashboard. The data basically was scrapped with the use of beautiful soap framework, and it was from various airlines. So in this particular thing, we can choose the airlines, let's say British Airways. So it's showing us reviews and then recommendations and then seat type and various other things. Also, we have here to choose from here. So this is particularly the airways thing. So first, we'll show you the baggage scanning, in which the data was encrypted format. So we decrypted it using the darknet file. So we have just extracted the darknet file here, and we have find it the good CUDA version to satisfy the requirement. And then we have resized the images and color part of it, like RGB to BGR to RGB. And after that, the training part. And we have just focused on the weights of the YOLO model. And finally, the CNN training with the convolutional neural network. And here are the results of it, wherein it says like razor blade is of 68%, screw is 66, then handgun is 95, screw is again 92%. So this kind of result we received from it. Then next I'll talk about the weapon detection. In weapon detection, again, the basic files which we need here, we have extracted the data from the XML file, um, and then performed again the neural network based model training. We have worked with the Torch and TQDM library to see the progress here. And finally, the result part detects the weapon. The next part is about the violence detection or abnormal behavior detection. In this one, we have considered various libraries such as PIL and then GC collections deck and CV2 library to perform the operations with the image based data. And also, so same thing, YOLO 3 and object detection and convolutionary neural network we have implemented here. And then the violence detection happens. So there is like maximum max pooling 2D layer and then batch normalization, dropout. We have performed it here. And then we have trained the model using 100 epochs. In people tracking and counting, the last part of the videos, I have two different files in it, people counting and people tracking. So let's go ahead with the people counting. It's almost the same, just that in people counting, it keeps the track of the, like keeps track of the number, like a count of people. And in people counting, it just directly gives the number. Here we have worked with the KRAS convolutionary neural network, and then we have dropout, then maximum pooling, 2D layer, and flattened dense. This kind of parameters we have used. This is particularly for the epochs part, and then semi-log X library used for the optimization. And then finally training with the epochs of 100 and batch size is 32. And this is the graph which we received from the mean absolute error point of view and the validation loss. So from each of the image, it is, let's say this image. So number of people is like greater than equal to 35. In this one, 41, 44, 41. So this is people counting. And here we are done with all the coding part of the project. So thanks for listening.